Welcome back to Razmafsar TV. I'm really happy to have Mahsa Bakherad back on our channel. Hi, Mahsa John. How are you today?
Hi, I'm good. How are you?
Thank you very much. And I really appreciate that you agreed to come back and to talk to us. Our last talk was very, very interesting. I mean, we got lots of good feedback from many viewers, fascinating discussion about corrosion engineering. And today we are going to talk and continue our talk about corrosion and metal corrosion, and specifically the cost of corrosion on human civilization. Could you please elaborate on that a bit on our talk today, please?
First of all, thank you so much. It's my pleasure. Thank you to invite me again and for reaching out to me again. Thank you so much. Regarding this subject, the reason I picked this subject to talk more, and I like to explain more about this subject, which is corrosion costs on human civilization, is we have a collapse for one of the big condominium in Florida, Miami, Florida, in US, and 94 people died. And the main reason was corrosion, because there was the reinforced steel in the cement for building of condominium, and because the environment there is close to ocean and salty, and nobody had a routine corrosion assessment and risk analysis. So actually, as I read in the news, I think they did some of this risk assessment, but it was last year, so too late to understand there is a corrosion. And then they decided to go and fix the problem, but it was too late, and too late to let people know about this problem. And the collapse happened before they fixed the problem. So this failure happens all the time. Is not the first time. We have this failure in gas pipeline in California a few years ago. I heard about the Pittsburgh gas explosion, gas line explosion, and most of the time we just think we need to see the something like a metal, and this is okay in contact with a wet environment, so after a while we can see visually this is a corrosion. But we have lots of hidden metals in the structure and in the and everywhere, and it could make could be collapse or can be failure. So it's really important to talk about it more, and I think talk about these keywords: corrosion analysis, corrosion assessment, risk assessment, and failure, root cause of failure.
Mahsa John, I have a question for you. Let's go back to Florida. I know most of our viewers are from the United States anyhow on this channel, but there are also many from other countries who don't know what exactly happened in Florida. So Florida is, of course, is ocean, is salt, is humidity, and many other factors. My question to you, was this building old? Was it an old building?
I think it was for 1974, if I remember correctly. And at the beginning, because it was in the code, everything from the metal should be, we need to calculate the corrosion rate and make sure this is based on the design life. We can use this metal, for example, for 25 years or 35 years. So I think there wasn't this calculation at the beginning, or if there was, nobody cared about these corrosion rates indeed. And they just built the building, and it wasn't sealed. All these metals wasn't sealed, and if there was in contact with the electrolyte, somehow there was a pool and there was a leakage. And because we have some windy weather and they have lots of storm, flood, and all these problems during all these years caused some salty water leakage to the cement. So
was it, Mahsa, was it in the foundation of the building, the problem that made the building collapse?
no, it was in everything, all the column. They use I think they use it in the, not just the foundation, all the structure. It was connected by the metal structure.
And then what happened? All of a sudden, the building collapsed like an explosion, as if an explosive.
No, I think a portion of it start to be collapsed, and then because it was heavy, it destroyed the other parts. But you know, I think the small section it was remained, but obviously most
and
of
people were at home, and then of course
yes. And there was no time to run away from the building, so they found under all the collapsed building. So I think it took maybe 10 days to just find the bodies. So it was so sad, and some of people didn't know what is the situation of their family because they're looking for the bodies, and there was, I think, lots of missing bodies, and they could save some people, but you know, most of them died.
Terrible. Yeah. Okay, and the reason is, as you mentioned, that because you know that's a very good point. They are buildings, and then who's going to check now if the building still needs to be checked regarding if the metals are sealed, and no one is going to do that. Correct? Am I correct?
Yes, and you know, this is what happened in the building. But the subject is, I think, in the whole world, we have something like several trillion dollar per year. We have this collapse, this failure. And I think most of them in US, I think something like 1,000 billion. I'm not sure about the number because it's changed every year. But it's a huge number. But if they have some assessment and if they care about all these estimation at the design life, so we can save people, we can save money, we can save economy and everything. You know, the material doing as their properties. We try to use it in a different way. For example, in nature, we have iron ore, which is Fe2O3, so iron oxide. But we try to change it and do it as in the way we like. For example, in the building, as a pipeline, we melt it, we add some additive, some other metallic component or whatever to just try to shape it, try to heat treat it, and so many things that happen just because we want to get it ready for the purpose we like and use it in the nature. But Mother Nature didn't actually hate the thing. She didn't create it, so she tried to back it everything
to its original stage, right? Oh God, you're right. They want to go back where they were.
So
right?
this is a cycle. So materials doesn't fail. The people fail actually, because we try to use something, but we sometimes forget to have a good assessment, estimation, and our design is not perfect. Actually, the way of being constructed is not perfect. And so many things maybe happen, like an earthquake, flood, water, everything maybe is out of our hand, maybe happen. So I think it's really important to just have some assessment and inspection to make sure everything we try to use it's it it's worked as the design. Because if we don't care about all these, the failures suddenly happen. It's not like that. We can every moment we can see visually, okay, we are good, but some of these things, like a small track, maybe change to fail all the building, the huge building as just a one moment.
You know, I was just thinking about something. Imagine there is a condominium and then there's a big building, or I don't know how tall this building was, and then people have bought condos, apartments, whatever in the whole block. So either they're mostly owners, or okay, if they rent, that's not that huge issue. But for example, you and your team come and recognize there is a metal problem and fatigue or corrosion and so. Now, what happens to people? I was just thinking about it. Should they now leave the building and go somewhere else? And then the building will be demolished and newly built? And then if yes, who's going to pay for all? Insurance?
I'm not sure about the regulation of insurance,
Yeah.
but you know, I think for this case, it was something like 50 million, if I remember correctly, to just fix the problem. So yes, they should maybe we could have the people inside. I'm not sure about what was the exact problem or what was the purpose of the repairs. But I think the estimation of the cost of repair was something like $50 million. But right now, you know, all these people died, and I think more than maybe 100,000 more than these amounts they need to spend to just have a new building.
Yeah, of course. Of course. You know, because we know it as well, you know, in Europe, I mean, the US, everywhere is the same. Sometimes, you know, all these building societies or companies try to save money. They try to, you know, save some costs here. Some, you know, in ethics, in business ethics, we always talk about that, right? Or ethical issues, you know, and then I was just thinking, is it because of
So
that?
that's why we have a term like a risk assessment. So if you go for example, we have a regular inspection. We have this thing for right now, I think for all fuels, we have this regulation, and we need to go for gasoline every year and check, and sometimes it's bi-monthly or even monthly check inspection to make sure there is no leakage, there is, and based on all the data we can have, we can estimate it, what is actually we can calculate it, what is the corrosion rate in actual place, in the actual environment we have, and then estimate what is the remain life.
Yeah.
And if it's very short, how we can extend it. Like last time we talked about cathodic protection. It's a one way. Sometimes we can apply a new coating. Sometimes it's too late. We need to just replace a section. But at least for safety, we don't have explosion or sudden failure. So I think most of the time it's we can save in a cost even. And for the case like this building, is really important to have a failure analysis. For example, for this case, they right now all scientists work on it, and they know the root cause is corrosion. So if we know what is the root causes and what happened and what was the reason, so next time we can just at least reduce impact of these reasons, or just think about it, how we can stop this process or just reduce the speed.
So basically, please correct me if I'm wrong. No matter where we live, this danger is there, right?
Yeah, I think so. Because we use metal everywhere. And, this is happened from, I think, century 17 or 18, because we try to use metal everywhere. And in Asian, I think, for a sword event. So you can see if they, for example, they just try to go for a fight and it takes 6 months, if there was any inspection and just use the sword with lots of rust. So,
Yeah, that's right.
So I think it's really important to just have a regular inspection and have a good maintenance. So sometimes we know what is the problem, but nobody fixed the problem.
Yeah,
nobody care about it. Exactly what you said. The cost seems high, and okay, maybe later, but how many years later? How many days later?
yes, that's right. That's what they always do, right? It's really true, right? I remember, once in a building, and it was also it was in the States, and then I remember there was like a different condos, and then they had a swimming pool, and then when I went, I mean, I'm not an engineer, so I don't know, but just from my limited knowledge, and I saw that there was a leakage in one of the pipes, water leakage. So, and then the water was going, and then I told the guy, where does this water go? So yeah, it's water, no problem. I mean,
go to the building, to the all the cement, and go to the reinforced steel, and
exactly. And all of a sudden, it reminded me of that, right? And I told this guy, I think this is dangerous. I said, yeah, why should water be dangerous? That's what he said, right? Seriously. And he was, he owned actually a condo there, right? So they had a shared swimming pool. And then I just said, I think you should talk to the rest of owners here, and you guys need to have it fixed, because where does this pipe and water go? And he basically didn't care. And I was so surprised. Why didn't he care back then? Because okay, there is a cost of water, so I don't know how much water costs in that state. But besides that, I don't even know why. Because then what you said, this is going to actually increase the problem, right? Of such a,
yeah,
it does, right?
yeah. And last time we talked about in some of the industry, they don't use, actually they use mechanical engineer or chemical engineer as a material engineer.
Yes.
Because they think, for example, mechanical engineering covers everything. So they know about everything for sure, but for example, risk assessment, it's something very specific, and sometimes even the corrosion engineer doesn't know all the details. So it's really important we have a certified people doing this. For example, a certified corrosion engineer, certified laboratory, and everything should be based on the science and standard and the code. And for all these specific things, we need to follow all the regulation, and the certified people, certified engineer is the best person they can estimate all these things.
Let me just ask you another question. Imagine you're called to go and check in a building. So you're going, there are pillars, there's foundation. What kind of equipment do you have to measure what's wrong with the metal in the building? What do you do normally?
No, sometimes because it depends on the structure is different. Most of the time we need to have the drawing, and for some of these, I'm not sure about this building, it happened in Florida, but most of the time we have a drawing. So we know where is the metal. So based on what we have different testing for it's a NDT, non-constructive testing, and we can have with a there is different way, but I can name it's for example with an X-ray or with penetration test. They can understand if there is a crack and what is the length of crack, and based on the material they use for that structure, it's a steel, it's a cast iron, or it's copper, or whatever it is. What is the essential crack for it? So based on the length of crack we have and the corrosion products we have at that portion, we can and also this is a testing, and beside that we can calculate it based on the environment we have, the soil resistivity, based on all the factor we can see in the actual and physically in the place. We can calculate it like a design life. Design life is the like everything on the paper, but in the actual and physical environment, we can test, do all the testing we need to for a design, and then we can calculate it, what is the corrosion rate, actual corrosion rate. Sometimes the environment is changed during the time. For example, it was a flood, and for example, for few months, couple of months, we had 2 feet of water. So it caused a problem. We never seen something like that in the design. When we design, we can calculate everything for 25 years.
Yeah.
But we don't know if the flood happened. And if the flood happened, is different in somewhere like a Florida or in a desert.
Yeah, right.
So,
You know, for example, we had in I live in Frankfurt, but where there is like in northern parts, I mean, away from us, that we had in northern part of Germany, not very north, but towards the north, we had lots of flood and many people lost their lives, and many houses and villages were really badly flooded. And now they were like under water, sometimes for days, some places for weeks. But now all of a sudden, even okay, when the flood and the water recedes, then the problems are going to remain, right? After what you told me.
yeah.
Right? You know, I never thought about that. But what after talking to you, so okay, now the water went away, they cleaned it, but you can never tell what happened to the construction or to the structure of the building, right?
Yeah, right, exactly right. I was in Houston, and I think in 2017 we had a huge flood.
Yeah.
For 7 days, if I remember correctly, for 7 days we have a heavy rain with lots of. It was a windy, and so when we have a windy weather, so the water goes through everywhere. It's not just like just water raised on the floor. All the building have a rain for 7 days, 8 days, and everywhere was closed because of safety. All the plants, all the field working, and everywhere was closed. And I remember that time we have this regulation in a chemistry or petrochemical plant. Usually, after the flood like this, there is an inspection.
Okay.
They're going and check everything, and if everything looks good and dry, they can start working. But nobody check about the building. Nobody check about, for example, the other things. There is a hidden metal in the structure, but they also in maybe they have an impact of this water.
Absolutely, this is right. So can you, after such a flood, Mahsa, dry the construction in a way that it's not going to be dangerous for its integrity?
Not sure how we can draw it. Depends on the building, the size of building, the lots of items. But I think if there's an inspection, if they have a checklist and make sure it's safe,
Yeah.
so it's good. It's good. I think if we can have this regulation, because we already have all these for an industrial area, but it's good to have all these regulation for I think for a living is more important maybe.
Yeah, of
You
course
know,
it is.
if something happened in the field, it's really dangerous, and maybe some personal cause of uh, losing some people in there. But in the like this, like a condominium, it's so many people just sleeping there, cooking. So nobody knows something like this maybe happened. But in the plant, there is lots of safe area. There is we know about the exit, and I think it's if you want to compare, maybe in the building like this condominium is more important because many of lives is there.
Mahsa, I have a question for you. Imagine we have two buildings. Let's say one of these buildings is an arid and dry area, and one is in a moist and wet area. So am I correct to assume the building which is in moist and wet area needs more attention and more
For the
care?
corrosion.
Yes.
For the corrosion, yes. Yep.
Okay. Corrosion, yes.
Because for the corrosion, we need to have corrosion cell. The corrosion cell means we have two metals. One is active, one is anode and cathode, and we have an electrolyte.
Yeah.
So whenever you have an electrolyte, which is gonna be soil or the water, actually the water in the soil. If the soil is dry, you have less electrolyte. So when you have less electrolyte, the electron movement is more difficult. So everything depends on the electrolyte you have, and even if there is no different metals, like this case, you have just one metal, but one portion maybe you have more stress. One section you have a bend, or the chemical composition of this steel bar is not uniform. So the small place gonna be anode, the small place gonna be cathode. So even you have one metal, maybe you have lots of anode, a small anode and cathode on the surface of the piece of metal. So whenever you have electrolyte, the corrosion may happen.
And now, if I come and ask you something, now imagine you have a beach house or a building. One is close to water, ocean, salt water, and so, I mean, the air, of course, and in a wet area, temperature, and another one the same, close to water and sea, but in an arid area or dry area. Would it make a difference as far as corrosion is concerned?
Yeah.
It would,
Yeah.
it still does.
Yeah, exactly. And I think it's better to just mention this. We talk about big structure. They use metal as a reinforced metal inside the for a structure. I'm not sure about the Europe, but here in US, most of the houses, small houses, most of the houses building are from wood. So we don't have this problem.
Let me just say something to you about the constructions, because in Europe differs. You know, Europe is very small compared to US, but every country has its own culture in different things, right? Let's stick to Germany, which is the strongest economy here. Germans have a saying, they say, you're going to laugh about that. Americans build a house, right? And a wind comes and the house goes away. Germans build a house, you need many B-52 bombers to keep bombing it until maybe it gets a crack. Because there are castles in Germany, they make the houses so expensive. They are really so solid traditionally, right? Traditionally.
Okay.
So you needed, all the, Marine Corps should come and tell you how to destroy this damn thing because it's so solid. And but it's in Germany like that, not in everywhere in Europe it's like that. Because you asked me, that's why I started to think about that.
And
Right.
actually, it happens in Iran. I'm not sure, do you know about that? Or the design life maybe is 20 years, but nobody keep the house for 20 years. They redesign the house each, for example, 3 years or 5 years. So never meet the design life. They just, all the changes is a lot in Iran, especially in Tehran.